Algebraic expression to equation. So we have done the whole video on expressions, and now we know how to translate a phrase into an algebraic expression. And now in this set of videos we'll learn how to translate a sentence into an algebraic equation. Well, I've seen most of the books that they spend all their time in writing equations and solving equations, giving very less significance to expressions. But actually expressions is a lot more. Now here is an example which you will appreciate and understand what I'm trying to say here. Now the simple question is, what is the difference between 2x plus 1 and 2x plus 1 equals to 7? Now just talking about expressions and equations, I can say one thing, that is 2x plus 1 is an algebraic expression. Okay, it lacks equal to sign, so it is an expression. On the other hand, 2x plus 1 equal to 7 is basically an equation. Do you understand? So that is a major difference between the two. We have an equal to sign, and that makes it an equation. An expression lacks that equal to sign. It has all the other features. That means some operators like plus, minus, multiplication, division, some numbers and variable, one or more, correct? So both are kind of similar things, but they represent two different ideas. So one is expression, the other one is equation. Okay. Now, which is more powerful? Let me just put them head on. So, that's a great question. Which is more powerful? Well, of course you will say equations because you have been bombarded with equations left and right, but you don't really touch upon expressions. But I feel expressions is which takes the top position for me, okay? So it is expression. I'll show you how. Can you express 2x plus 1 on this graph? I know this is like fizzled out graph, but then let's try to draw and express 2x plus 1 on this graph paper. Now those of you who haven't learned lines and to draw, what you can do is you can make a table of values, correct? So let's make a table of values here and then figure out how to draw. Okay, so that is a good exercise before we get into equations. So what we have, we can put different values for x and then find what is 2x plus 1. So let's start with 0, for example, right? So I'll just take some positive numbers and then negative I won't take in this example, but you can always complete the question, right, by putting more negative numbers. So x, if I take 0, so it becomes 2 times 0 plus 1, which is 0 plus 1 is 1. If I write x as 1, then I get 2 times 1 plus 1, that is 2 times 1 is 2 plus 1 is 3. Then if I write x as 2, I get 2 times 2 plus 1. 2 times 2 is 4, 4 plus 1, 5. Now if I write 3, then it becomes 3 times, I should write 2 times 3 plus 1, 6 plus 1, 7. As you can see from the pattern, it goes by 2, right, that number each time, and starts with 1. So let me write x values here and 2x plus 1 on this axis. So when x is 0, I get a point at 1. Let's say this is my point. If x is 1, then I get point at 3. So we can't see much, so what we'll do is we'll assume. So it is 1, 2, 3. Okay, that's it. Now for 2, x is 2, 2x plus 1 is 5. So it is 2 more, right? And there is a pattern. It is just going in this order. Just keep on increasing. So this is our expression. Mind it, x could be any value. Any value means x could be like 1.1, 1.2, 1.3. So since x could be any value, what I can do is I can join these points with a line, right? So I can join them with a line. Let's say this is my line. That is the line, correct? So this line represents the expression 2x plus 1. This is what I'm trying to show you. Now, what is 2x plus 1 equal to 7? That means equal to the value of x which satisfies this equation. That means the value of x that will make the left side equals to the right side. This is what we'll be dealing with in equations. To find the value of x which can make the equation true. Now what is that value? Well, that is here, right there. So if x is 3, then we get 7 for 2x plus 1. So that means when x is 3, so it is 7, so this is this value. So 2x plus 1 equals to 7 actually is this point. Do you understand? On this line. So that is what I want to show you as a difference between an expression and an equation. I hope you appreciate the point. Well, you can say equation precisely defines a point on the whole plane of infinite points, correct? And the expression is just a simple straight line. Anyway, but this is just to give you an idea. And now let's move on to equations. So when we move on to equations, we have to remember two things. One, it has the equal to sign. And second, the value of x we are interested in is to make this statement true. That means left side equals to right side, and most of the time it will have a unique value. Well, it can have many also, but most of the time it will have very few values, okay? And that is what we need to calculate. And when we say find the value of x or solve the equation, what we are trying to say is this particular point. We are trying to say is find the value of x which can make left side equals to right side, or which can make the equation true. That is what we say when we say solve an equation, right? It's always a good idea to solve and check. So in this case, we got answer as 7 for 3, right? So the answer here was x equals to 3. Answer is x equals to 3, right? It is the x value which is the answer, okay? So solve and check means plug in 3 here. So if I write 3 instead of x, what do I get? I get 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1. Well, that is equal to 7, and this is equals to right side. Okay, so that is solve and check. You start with the left side, plug in the value of x. I'm assuming the variables are put on the left side. Okay, for the time being. Either way, you start with left side and then with right side and ensure that both are equal. That's the whole idea. I hope you get, and let's now start with equations. Thank you and all the best.